All right. Welcome, folks. Appreciate you joining us in. I see people are joining now. So I will, as people are jumping in, thank you very much for joining Ask Mayfield Anything. And when we get going here, one of the things that we request and we actually encourage folks is sending questions in. So we have a question and answer feature within Zoom. Hopefully y'all are familiar with that. So that's the easiest way for us to track those questions that you have coming in. We had a few get sent in ahead of time. So we'll go ahead and make sure that we incorporate those questions as well. But as we're going along, I'll keep an eye on the question and answer section. And so make sure that we are, hopefully answering questions as you bring them up. So thanks very much for joining. Just want to do a few introductions and then we'll jump into our topic at hand. And so real quick, for those of you who may not be familiar with Mayfield Renewables, we're a consultancy. I formed the business in 2007. And so we have an engineering group where we do consulting engineering, and we're working with contractors. We're working with folks in the field doing engineering work, producing plan sets, doing studies on power system studies, feasibility studies, and things like that, which we'll kind of allude to and talk a little bit about during today. And then one of the big things when I founded the company was around education. And so we offer education as well. And part of that is doing webinars like this. So bringing on smart folks and having discussions around timely topics within the industry. So that's what we're here today for. So we'll kind of jump into that. And very lucky to have 3 guests with us today. And we're going to be talking about the C&I space, energy storage systems, and the C&I space. And so matching up products and projects. And so do a quick round of introductions here before we get going. So Chuck Rames, we have ESS Business Development for Socomec. And so Chuck, will you introduce yourself for our audience?
In a minute or less. I have been in the renewable space for 15 years, half of that in photovoltaics, including with major module manufacturers, working on some of what were then the biggest PV projects in the world. The last 7-8 years in energy storage. First working with my friend and colleague Andrew Tanner at Growing Energy Labs Inc., Jelly, now acquired by Hanwha Q-Cells. And for the last 6 years, working with Socomec to bring a new generation of modular outdoor energy storage systems to the American market.
Awesome. Well, thanks for joining. Really appreciate it. Next up, we have James Naviaux, Global Partnerships and Strategy from ESS. You're based out of New York. ESS headquarters here in Oregon, where we're located. So, James, will you give a little introduction for the audience?
Sure. Thanks, Ryan. And congratulations. You pronounced my last name correctly. So I'm very glad we rehearsed that. So I've been with ESS for almost 5 years and really around kind of product launch, commercial strategy, globalization. And I just think in those 5 years, what's happened to energy storage as a space? I mean, it's almost unrecognizable, and the growth and the momentum and the kind of technologies that are really coming to the forefront. And I think about those 5 years relative to ESS, and we play in long duration energy storage. And while hydro has been around for decades and even centuries, what's interesting about the long duration energy storage market is it's really starting to take shape and form. And I think with that, I just want to say grateful to Mayfield and my colleagues on the panel, because there's a lot of technologies out there. There's a lot going on in the space. So sessions like today are really helpful for the general market to understand what's out there, what's available, and what's going to be the right fit for my particular project or use case. So thanks for having me, and I'm looking forward to a productive session today.
Awesome. Thank you. Thank you for that. And then Andrew Tanner, we have Chief Technology Officer from Yotta Energy. Yotta is a company that we've been working with in the past. And so it's great to have you join us again, Andrew. But for those of the participants, will you do a quick introduction for you?
Yeah, absolutely. Thanks, Ryan, and good afternoon to everyone joining this webinar. Looking forward to an engaging discussion, and want to echo what Ryan said about dropping questions in the Q&A box. I think the most enjoyable aspect of these sorts of engagements is really addressing the questions that do come in. I've worked myself in renewable energy for 20 years, explicitly in C&I energy storage since 2014 as one of the early employees at Jelly, which was a company that was getting going at the same time as STEM, Green Charge Networks, Demand Energy, and we were all attempting to crack open the C&I energy storage market. Fast forward 10 years, I think that inflection point has finally come, which is very exciting. But what motivated me to join Yotta at the beginning of 2020 was really, I didn't see this as a challenge so much as on the technology front, as much it was on the integration side of things. And so I've been supporting the pioneering of an entirely new format for energy storage that emulates that of PV modules. And you can see our technology over my shoulders, and bringing that to market, wearing multiple different hats over the course of the last three or so years. So I'm now CTO, but I've got a breadth of experience on the other side of the aisle in business development and sales as well.
Excellent. So, and yeah, thanks all for the introductions. And to build off of what Andrew was just saying a little bit too, one of the things that we talked about as we were preparing for this was how each of the companies, our guest companies, they're serving different markets, they're serving different spaces. And so this is, I think, a great opportunity working with this group, be able to find the different ways that different technologies can meet the projects where they need to be. And so I think this is just a great group to have. Everybody brings their own perspective, and being able to, I think, add to that conversation. So with that, we will, get into it. Matchmaking C&I products to projects. And so really focusing in on ESS systems and trying to, put that together. One of the things that the reason why we, I think, kind of came up with this and really focus on C&I, one is that's a big focus for Mayfield, but also talking with folks, we get a lot of feedback that people are maybe not feeling like there's a lot of products out there. And so being able to marry those up is one of the things we want to talk about. So what are the market drivers? Why are we, I think a lot of this might be known for a lot of folks, but some of the things that we're seeing out there, we're seeing it, that our guests are seeing it as well. Of course, the IRA has a fair amount to do with it. We're now seeing this investment tax credit around storage systems themselves, and that's helping drive sales, helping drive people being able to put this into place. As some of the questions that have come in, price is always a big thing around this, and how to effectively make it a economic solution for the building owners. Another one that we are seeing a lot, and I would love to get a little bit from the panel because this came up in discussion during our prep time, but talking about reliability, resiliency, if you will, for buildings, and especially around weather events. I'll kind of kick that off and just mention that we're seeing a lot of it. Being based in the Northwest, we see a lot of this talk and this worry about earthquakes. We were just talking about earthquakes as we were getting ready for this as well, kind of driving some things, other things within the West. But that's it's not a weather event per se, but it is a driver for resilience and reliability systems. And so, that's something that we're seeing. There's weather events across the nation. It seems like every time we turn around, there's some new weather event happening somewhere in the nation that's driving this. And it's not, there's some learning, I guess. And, this is akin to, we're going to focus on C&I, but this is somewhat akin to residential market where homeowners not knowing what they don't know. I would think we could say the same thing about business owners. Andrew, we were talking about that yesterday, just being able to set the stage and set the businesses up for, what their expectations are around having storage in a resilient type way. I don't know if anybody on the panel has anything wish to add on that one.
I mean, just to add a little bit of color, when resilience does come up in conversation at commercial industrial, often there's a misunderstanding that they're going to be able to back up the entire building with an energy storage system. And sometimes they can, but more often than not, that's not going to be the case. But they also don't know what they want to back up, and they don't need to back up everything. So
absolutely,
there's a lot of engagement that's typically needed with a building owner to understand their resilience needs.
Yeah, 100%. And I mean, that we could say the same thing about residential. A lot of residential people, homeowners get it in their mind, put in a battery, you can run everything in the house for as long as you want. And that's not necessarily the case. And so setting those expectations and knowing what those are, doing feasibility studies, things like that. So yeah. Some of the other drivers, we have NIM 3.0, as it was pointed out in our discussions as well, that's maybe driving on the residential side. There's going to be some drive on the commercial side as well. But that's definitely making that come to the forefront of discussions and making people think about it. So that's definitely, something that's out there. And then of course, Title 24 in California. So, not trying to focus on California specifically, but as we know, as we all have seen within the industry, what happens in California tends to make its way for the renewables industry. The rest of the country follows suit typically. So we're already seeing it in some other markets where there's talks of net metering getting changed, utilities going after that and things like that. So Chuck or James, do you guys have anything else? Are you seeing from what you're talking with your clients and your customers on market drivers?
Well, I think what you said about California kind of being on the forefront for the rest of the country and the rest of the world, I think is spot on. What we see is when you get to a certain renewable penetration in California, maybe that's approaching 30%, storage is mandatory. And so I think California is in that phase where storage is required and longer duration is becoming more and more of an interest in that market. But I think as we continue to introduce more and more renewables, you need storage. And in California alone, terawatt hours of clean green energy is just curtailed every single year because we don't have enough storage to move that around to when it can be used to spread to a 24/7 decarbonized world, which is, I think, what we're all eventually on a path towards in the future.
James, I wish more of the customers were focused on the state's climate goals. That's why a lot of us are here, but there tend to be a little more, they're practical Americans. They want to see, in most cases, they want to see a return on investment. So the challenge is to understand why they want to look at energy storage, but to always frame the first proposal in terms of return on investment, and then branch out from there and add more to it. Resiliency is a fun one because, yeah, like Ryan said about residential, people assume it will back up maybe more than it will, but it runs the gamut. There are some that the primary driver is to keep some industrial process going, and the resiliency is more important than the economic returns. But those are outliers. Usually, if the economic returns come first, then the resiliency adds on.
Right. Yeah. And understanding what those are is important. I mean, understanding how energy storage is going to play a part in whatever system it is. If they are demand response, what do those financials look like? How is this system interacting? How much control do the building owners have? All of those are important aspects. So I don't want to belittle the need for that information or gathering that for non-resilience projects as well. Okay. So I want to take a few minutes and kind of set the stage and let the audience kind of, hear from the different manufacturers, from our different representatives, and, kind of helping. I mentioned everybody's heaters are kind of meeting a different segment of the market and kind of coming at it their own way. So I wanted to give everybody an opportunity to spend a few minutes talking about that and really help set the stage for when we ask, we have some questions that we're asking and more of a roundtable. So first off, I'll let Andrew talk about Yotta Energy and kind of give us a overview on what it is, your product and what the market challenge you're addressing.
Yeah, thanks, Ryan. So we have innovated arguably the most novel form of energy storage, which is a panel level format that co-locates with solar modules on rooftops. Each battery is a single kilowatt hour in unit. So if you want 100 kilowatt hours, you'd have 100 of our modules. And typically, if people often say, what's the right size energy storage for a building? I can tell you after many years of doing analytics, it's somewhere in the 1 to 2 kilowatt hours per kilowatt DC of solar. That's your average. So we're either putting one of these under each solar module or one of these under every second solar module on average. Now, what are we addressing? I touched on this before. It's the integration challenge. The reality of commercial industrial energy storage is it's really hard. And anyone who tries to argue anything to the contrary doesn't have experience in deploying energy storage for C&I. What we've actually seen and what the data supports is that as the market has matured, the cost of all-in energy storage systems has actually increased in the hundreds of kilowatt hours of size. And that's because a lot of the fixed costs associated with deploying energy storage gets smeared across a much smaller system. And some of those challenges are, where do you put the energy storage? How do you connect that energy storage system to the main service panel? What we are addressing head on is where do you put the battery and how do you integrate it? And we actually sit in between the solar module and a 3-phase microinverter that we supply to the market, thereby existing on the DC side and not having a separate interconnection. There is therefore just one interconnection for the solar plus storage system. All of the design work that goes into the solar carries over to the energy storage system. And then lastly, by actually having a very small volume we had lithium iron phosphate batteries, one of the first to actually use LFP. So it's a safer chemistry, but inside every single aluminum enclosure, we have a layer of ceramic insulator, a phase change material, and a novel thermosiphon heat exchanger, which prevents the battery from getting hot, but also acts as a fire barrier. And during fire testing, literally the enclosure didn't heat up when the batteries were in thermal runaway. So arguably the safest or lithium technology available in market for the commercial industrial market segment.
Awesome. Thanks for that. Yeah. So it's definitely, I've enjoyed, learning more about it and working with you guys and seeing this product and getting deployed. And so it's interesting product and fun to, the designs around it and everything make for an interesting project for sure. So with that, we'll move over to Socomec. And so Chuck, if you can give us kind of where you guys sit in the industry and same kind of things, what are the market challenges that you're addressing for your systems?
So we're focused on small to medium commercial industrial. Everything I'm going to show you today it's 3-phase, it's 480 volts. It's a purely commercial system. It's not intended in any way to be used in utility scale applications. It's way smaller than that. So it's too big for residential. It's too small for utility. It's exactly right for many, if not most, of the C&I projects that we're seeing. So Socomec manufactures the power converter, from the converter modules to the switches to the chassis. We build the whole thing, including the system level controls and the microgrid controls. And then the battery we integrate with a lithium iron phosphate battery from the world's largest battery maker, CATL. And this gives us both a modular converter and a modular battery. So the little table at the bottom just gives you a taste that there are 22 UL certified configurations between 50 kilowatts and 300 kilowatts and 186 kilowatt hours up to a little over a megawatt hour. Others on the call have said that this is not an easy segment to be in. You're going to need to get the projects approved by building permits and electrical permits. There's going to be questions about fire safety. So we go out of our way to provide lots of certifications, lots of documents, lots of third-party engineering reports to make this as easy to sell as could be. And someone mentioned earlier on the call, I think Ryan mentioned, California now requires solar plus storage for most new commercial construction. And those products have to be on an approved list, running approved control strategies. Socomec is the first 3-phase system added to that list that meets all the certifications that are required. So it's a modular, scalable CNI energy storage system, and I would be happy to take more time and delve deeper with anybody that wants to learn more at a later time.
Sure. And then super quick, just for those who aren't familiar, and I probably couldn't answer this question completely. So the JA12 listing, is that the controls listing? Is that what you were just referring to?
Actually, it's the Energy Commission lists the hardware set. So it's on the energy storage systems page, hardware plus converter. And so there are requirements for the hardware, but also the controls software needs to do. There are 3 control strategies that are defined in JA12, and they're all on the CEC page.
CEC list. Okay, cool. Okay, thank you very much. And then finally, we'll have James, talk about ESS. The long duration flow battery, which is meeting again that third side of this that we're going to talk about.
Perfect. Thanks, Ryan. And I think when the spirit of this whole discussion is different tools to solve different problems. And just, what Andrew presented was how small and how dense the lithium-ion solution can get where it fits under a panel. And then you get over to the solution that Chuck is talking about, and that's a containerized system. Now you get to a flow battery where some of our limitations are around space. So our energy warehouse is our smallest solution that we have, and that's a 40 by 8 foot shipping container. So this is a 75 kilowatt, 500 kilowatt hour system. So at ESS, we have a kind of behind the meter CNI, and we have a front of the meter, large scale utility systems. But for today's, we're just going to focus on the energy warehouse. So first and foremost, what are we solving for? And that's really a up to 12-hour duration solution. So ESS falls in that long duration storage, 8 to 12 hours, but we're a battery that likes to be cycled every single day. So that's kind of the segment that we fit in the continuum. If you think about how we do it, I will take a moment to explain the chemistry, because I think lithium ion is ubiquitous. It's in our computers, our phones, our cars. But here's how our solution works at ESS. We have power modules on one side of the container, which you can see in the rendering. On the other side, we have a large electrolyte tank. That electrolyte is made up of iron, water, and salt. Really safe, really easy to source. The way the battery works is when we're charging the battery, we plate iron onto a membrane, and when we discharge, the iron goes back into the solution. But kind of the game changer and what our co-founders perfected is it goes through a rebalancing system, and that reconditions the electrolyte back to its original state. So because of this, we have a 25-year battery that has unlimited cycling with 0 degradation. So very different chemistry, very different performance characteristics than lithium ion. And, at the beginning, during the introduction portion, I mentioned that long duration energy storage is really starting to form in the last 5 years. And just kind of the demand from McKinsey and the Long Duration Energy Storage Council is looking at 34 to 40 terawatt hours of long duration in the US alone. And some of the reasons we'll talk about today with a couple of use cases, one on the CNI side being the reliability and business continuity, and then some of those areas that have a real increase in high fire safety assurance. So a lot of different technologies that we're talking about today, but this is kind of the segment that ESS plays in and how we do it and the characteristics that come along with our solution.
Awesome. Cool. So that's helpful. I appreciate all 3 of you taking the moment to go through that. And I know everybody can talk about their products for much, much longer. So keeping it nice and short is helpful, but helping kind of set that stage too for what, each of the companies are bringing and kind of these questions that we're going to ask. So, first off, one of the questions, so we're talking about matchmaking these products. And I think one of the things that we see quite a bit as an engineering firm, talking with clients and, I think in general, specifying products. And so this gets even into, pre-design, we're not fully into engineering design at this point, but I guess one of the questions that comes up a lot is, how do you assist prospective clients with specifying your product and, understanding what their needs are and kind of what that process, what it looks like for each of you. So we've got Socomec there on the left, so I'll just use that as our starting point. So Chuck, what is it that what are the questions you guys are asking? What is it that the contractors should be bringing to the table to make this kind of a smooth project for them?
So if let's go back to where we were before. Most of the projects will eventually be part of a conversation about economic returns. We might start with resiliency, we might start with some other engineering requirement, but eventually we're going to get to how does this thing pay for itself? So I think it's important to understand the customer's goals. What are they trying to achieve? And then start gathering data about the building and running it through modeling software and working up some financial models of what the thing could do. Often we'll see that customers come to us and they say, we want a size system. We want 500 kilowatts, 2 hours. And then we drill into it and like, why did you pick 500? Well, there's a lot of those available, so we're just going to price that, and then we'll go from there. So it's important to circle back and look at what are the returns for a given size. Would there be stronger ROI at this size or stronger net present value at that size? It's important to kind of find those numbers first before we dive into what for engineers and builders is the fun part, which is designing how to actually build the installation.
Yeah, and so we're getting, I would say, a fair amount of that, as well as, you know, sometimes matching or thinking about relating it to the PV size, and not necessarily thinking about kind of what those financial drivers are and what those technology drivers are. So Andrew, I see, you know, on this screen here, we're showing energy tool-based proposal. And so I guess kind of same thing. How are you guys at Yotta, you know, supporting the customers trying to size the system? I mean, at a 1 kilowatt hour increment, you have a lot of flexibility there. So how are you approaching that?
Yeah, so, you know, as Chuck mentioned earlier, we were colleagues at Jelly. So my background is in software and analytics prior to Yotta. And the reality is that, you know, understanding the value proposition of energy storage and the economic returns that it delivers is quite complicated. And one of the things that the folks at Energy Toolbase have done is simplify that. And so whether the battery is doing demand charge management or energy arbitrage or self-consumption for NEM 3.0 or demand response or grid services, they're able to, you know, dramatically simplify what that economic return is on an annual basis for that kilowatt hour. The reality is that as energy storage gets larger for a given installation, that return per kilowatt hour actually declines. And so you get to a break point if you're solving for an ROI, at which point it doesn't make sense to scale that system up any larger. The elegance of Yotta, of course, is in 1 kilowatt hour increments. We can take you all the way up to that break point and arrive at exactly the right amount of energy storage, or come back after the fact as well if a load changes and add more batteries, as simple as lifting up a module and, you know, disconnecting some MC4s and reconnecting the battery. But it doesn't stop there. Understanding, you know, design and how this is all going to lay out. We substitute for ballast, working with companies like Panelclaw, Solega, Iron Ridge, and others to actually integrate our battery as a ballast weight is also part of the offering from our sales engineering team. And then although you see a stamp on the plans there, we work with companies like Mayfield, who would actually provide ultimately the stamp drawings to submit for AHJ approval. So we're intimately involved in the pre-sales and easing developers and EPCs into, you know, what is mostly now their first deployments of energy storage with solar.
Excellent. And so James, kind of shifting over to you and what ESS, you know, looks at, you know, and I hear long duration and I'm thinking this, you know, where my mind goes are these resilient type systems. I mean, so how are you approaching, or, you know, when a customer comes to you with a prospective project, how are you helping them understand if this is the right fit, or if, you know, quite honestly, should they be looking at something different?
Sure. I think that's spot on, Ryan. I would say this is part of the most rewarding part about representing ESS and our technology is we can do things a little bit differently and unlock different kinds of use cases. I think Chuck hit on, you know, if a customer says, I want 500 kW for 2 hours, we get something similar. Like, we want a 4-hour battery, and then we say, well, why do you want 4? And you start looking at the numbers, you start understanding what they're solving for. And maybe it's a 2-hour use case and lithium is perfectly suited, or a 4-hour and then lithium is the right solution. But once you start kind of digging into what they're solving for, what's important, and then understanding the ROI piece, then we can unlock different kinds of use cases. This actual image is one of our projects in Pennsylvania, and it's a recycling facility, and it's located in a region with kind of an unreliable grid infrastructure, and they have a couple 2-3 outages per year, which ends up costing them about $120,000. So for them, it was really important to have a longer duration. They really needed more energy to be able to retain business continuity. So just on the avoidance of those financial hits, this solution paid for itself within just several years. But if you think about some of the arbitrage and what it can do, there's other economic ways that these projects can pencil. And I think with unlimited cycling, you're able to do different things. So a good example, and what we challenge a lot of our EPCs, developers, integrators is play offense with our battery. And what I mean by that is, can you find a cycle and a quarter or a cycle and a half? So maybe you're going to move 6 hours of renewables to the peak, but then you can buy energy in the middle of the night when it's the cheapest and use that for the morning peak. So now we've just delivered a cycle and a half. And so this is when the economics of unlimited cycling and a 25-year product really start to take shape. But because we have a new technology, we have to do a lot of this early on with our customer to change the mindset from just looking at lithium, because to be honest, that's what everyone been familiar with for the last decade, for good reason. So I'd agree with what Andrew and Chuck. It's really about understanding what that customer is solving for and being able to steer them in the right direction. And maybe it's your technology or maybe it's not, but that's a kind of a fun part of what we do at ESS every day.
So are you all, and this is to everybody here, so again, the energy tool-based proposals on the screen. Chuck, you talked about the financial aspect. So are you all in a position to be able to support people making those decisions? Are you guiding them along the way, saying, this is, the best return on investment? So, just to point out that that's something that we do. I just don't know how much, as manufacturers, you guys have that ability to be able to work with the clients and be able to help specify that product.
So Andrew mentioned Energy Toolbase, and we are also integrated with Energy Toolbase. It's I think it's perhaps the most widely used modeling software of its kind, and there's operating software and monitoring software to go with it. But there are, for example, if anybody on the call is a dealer for Qcells PV modules, then this product is available through the Qcells channel using the Jelly eSyst modeling software and Jelly operating system to run the system. Schneider Electric uses our hardware with their own proprietary software. PowerFlex uses us with their software, and so on down the list. So there are a number of modeling and operating software sets in market, and I just what I'm seeing is that more sophisticated customers will come to us and they might have already run those models before we get a first telephone call. But it's important to encourage every customer to just have these data points in mind as part of the conversation.
Cool. Yeah, Ryan, there's one thing I might add.
Yeah, please.
Relevant to software is, even if you've got the best hardware product, if the software that runs that hardware doesn't do what the analytics said it was going to do, there's a mismatch between the economic and the runtime of that battery. And that's, it's one of the things we were pioneering at Jelly, and it's one of the reasons why I believe Qcells ultimately acquired the company. Energy Toolbase has done the exact same thing, and similarly, folks like PowerFlex are looking to achieve this and not this. So when it comes to there'll be some more sophisticated audience members who are like, where's the bankability, right? It really is. There are multiple layers to energy storage that exist beyond just the hardware stack that I think is necessary to understand when we talk about the system.
Yeah, absolutely. And being able to, and then when it gets even more complex, when you throw a generator into the mix, things like that, it can get really complex quite quickly, and if you're not modeling that properly. And the other thing I would throw out there is just the follow-up. So once it does get installed, and making sure that it has been, the programming is correct and it's doing what it's supposed to do, is an important part of it. Missing, if the whole reason was to do demand response, demand charge reduction, and you miss that 15-minute window, then you haven't saved them anything. And so that's an important aspect of it, and part of the modeling and engineering aspect.
Right. I mean, ideally, the modeling, the operating, and the monitoring are all from the same company, and they're all in the same format. We'd like our customer to be able to look at a proposal this year, and then next year look at monitoring from their installed system and see the financial returns presented in the same format as the proposal they saw earlier.
So here's a question that came in ahead of time. I think this would be a good spot for it, and this might be overly loaded, but the question, I'll just read it as it was, and we can talk about it. But so what makes a bad project that you look to avoid? So what attributes do OEMs use to qualify out prospective projects early in the sales funnel? So, what if somebody were coming to you, what are some of the, I guess, red flags? What are the things that are, the projects make it seem untenable to even put in?
You want to go for it?
Well, I think it's straightforward for us on the long duration side. I would say a 2-hour battery or 4-hour battery, that's just not where we play. And then obviously where space is going to be an issue, that's just not, those are just non-starters for us.
So bad projects, it's an odd question. There are customers that come to us with a partial understanding of what energy storage can do, but that doesn't make them bad customers or bad projects. It means more education is required. A good example is a customer that's looking at energy storage as for diesel replacement, and they're only, when they come to us, and the only requirement is it needs to provide X number of kilowatts for a duration, and that's great. We can do that, but we also have a responsibility to educate. This thing's grid connected. It could be working for you. It can be doing stuff every day that you're contributing to the larger energy community. You're helping with that green transition, and you're being paid for it. There's return on investment. And so to share what are all the value streams that are available here. What I see is that there are projects that just don't pencil, but for projects that make economic sense, I don't think there are bad projects.
I like that perspective. Not bad projects, just maybe inappropriate solutions for the project itself.
So I was hoping that Chuck could tee up bad project as a project that he has nowhere to put his batteries. That's one of the things that Yotta is addressing. But look, a technology like Chuck certainly has a place, particularly when it comes to resilience, microgrids, and things like that. Where Yotta is looking to play, 74% of rooftops are less than 10,000 square foot in size, which means approximately 100 kilowatts of solar or less. Using that principle I said before, 1 to 2 kilowatt hours per kilowatt DC of solar, that is the sweet spot for Yotta. So, some would say the project is too small. We can't make the economics pencil. For Yotta, it's ideal. We'll see probably I think somewhere between 50 and 200 kilowatt hours being the median size system that we deploy. And we're able to turn a bad project that couldn't pencil into a good project that does, as a consequence of coupling the storage with the deployment of the solar array and displacing ballast in the process. So our modularity, the ability to conform to the kilowatt hour, to Title 24, these are some of the strengths that we're addressing, and therefore, we don't see a clear bad project as a consequence of that modularity.
Sure. And I think, Ryan, this goes back to how you teed everything up. This is exactly why we're having this discussion, because there's a lot of different tools that solve different problems and can do unique things.
Sure. Yeah, no. Yeah, perfect. I'm gonna move on to our next question. But yeah, thanks for all that. So one of the things that, every single day we all get, I'm sure everybody on this call, everybody, all of our participants, safety is a big concern within the industry. And we have a few questions already that are, specific around safety. So, how does your product address safety concerns of the industry? And I think you've all touched on it already. So, one of the things that, I'll start the conversation with another question that came directly from one of the viewers in asking about, commercial property owners are concerned with placing battery systems on, in, or next to their buildings. And so, the question that came in was as the industry as a whole, which maybe is a little bit different frame, but around specific products, how are you all approaching that safety and being able to, I guess, assure or, help people feel a little bit more at ease with placing these storage systems, on or in their buildings?
So I could start with kind of a nuts and bolts answer, which is these systems need to go through an elaborate approval process. There's electrical permits, building permits, there's fire rules. So what we do, first of all, have a product that's very high quality components. And then it has all of the certifications that we need for the California market. And then we can go one step further and we can, here's a letter from a professional fire engineer outlining and explaining why this thing can be installed in a code compliant way, thus and so. And there's a lot of support after a project is, an order is received, to support the customer through the permitting and interconnection process, because it's not as standard as it should be. There are still, even in California, we'll get random questions all over the place that we've never seen before, and it goes back to education. These are the standards. These are the requirements. Here's the documentation that shows compliance, and that's how we move through this. And as far as the emotional journey of the customer, knowing that all of these actual procedural things are in place often goes very far to taking an uninformed fear and turning it into a more informed understanding of why this can be installed.
Yeah, and I think one of the things that as an industry we rely on, fall back on a lot, there are the safety standards, UL 9540. There's a testing protocol, 9540A. And so I guess one of the, questions that I would have for this group, that's obviously, getting those listings is important. And this kind of gets into, design and engineering, I think a little bit, leading into our next question some, but how are you all helping contractors and others, looking at those reports, specifically the 9540A, and basically discerning what those tests are, what they're saying, how to interpret those results, I guess, because one of the requirements out there is provide that to the AHJ. Well, the AHJ is not a fire safety expert. So how are you all helping them in that sense?
Yeah, if I can jump in there,
yeah,
right?
Of course.
So, when I say putting a battery on a roof, I'm sure there's more than just one person on this call that's thinking, oh my God, that's the most insane thing, to do, right? And that's where a lot of people start off. And in fact, the codes and standards never even anticipated a battery of our format being deployed, in a distributed manner on a rooftop. We, like, Chuck and James, we've gone through all the certifications and more ULs than I think any other ESS technology as a consequence of co-locating on rooftops. We've engaged a third-party fire protection engineering firm to author a report that can be shared with AHJs that simplifies what can be quite a dense report that is, unless you're well versed in 9540A, it's just, there's too much information there, and the AHJs really need a simplified manner of understanding it. We, similar to what Chuck just said, are in the trenches with those developers, EPCs through the permitting process. which often involves directly engaging with the AHJs or the chief engineers of the fire department, who start over here with, that's insane, why would you put a battery on a rooftop? And they end up with, oh my God, you've actually addressed every single concern we have for stationary energy storage. So we are at the infancy of adoption of energy storage, and consequently the level of engagement and education is a necessity to progress this market. And it's, in many instances, it's one at a time, but it will gather momentum, and it will, I think we're going to move to a more seamless approach to adoption.
I think, and just to add, what Chuck and Andrew just talked about is the tremendous journey that lithium ion and the safety characteristics and what the industry has done is continuing to improve every single day. But as I mentioned, ESS is a different kind of technology. And so because we're based with just iron, water, and salt, we're very benign. We have no risk of thermal runaway. An example of, I mentioned one of the fun parts about representing ESS is we get to unlock different kinds of use cases. So this is a picture of Schiphol Airport. This is in the Netherlands. They have very aggressive decarb goals. So by 2030, they want to be carbon free. Part of doing that is decarbonizing the ground operations on the tarmac. And we all know you can't check a bag with a lithium ion battery in it, let alone they don't want lithium ion batteries on the tarmac. So we have one of our energy warehouses right now being commissioned at the airport to support this effort. So once again, it goes back to the theme. Different technologies can do different things and unlock different kinds of use cases. But this is one that we're excited about. And it's ways that, the safety characteristics of our technology maybe can change the way people think about using energy storage.
Well, that leads into a question. I think this is going to go to Socomec and Yotta. Somebody put in the questions here of, why use lithium for stationary batteries, and, the comment, weight and bulk reduction don't have the same value as for transportation. From what we've seen, the systems we've done, we're still space constrained in a lot of cases. And so especially commercial rooftop, we're seeing a lot, commercial rooftop PV, I should say, very space constrained. You get inside most C&I spaces, very space constrained, putting things outdoors. And so I guess that would be my perspective on it. We're still want something relatively dense. There are going to be the cases where that's not the case. So I don't know if you guys have a different answer on, on that why use lithium type question.
So I would just start with the fundamentals. 95% of C&I energy storage or more, maybe 98%, is lithium ion. So it's far and away the commercially dominant technology for C&I in this 2 to 4 hour market. And I would make a distinction between nickel manganese cobalt, which is what goes into cell phones, laptops, high performance automobiles, and lithium iron phosphate, which we learned about maybe 5-6 years ago as an emerging technology for stationary storage, but we're now seeing its energy density has improved to the point where a lot of the low and mid price point EVs will also be lithium iron phosphate. So it's about price for performance. And that performance is, not just 1 or 2 cycles, but many thousands of full cycle equivalents over time. Just the financial side of this at present points to lithium iron phosphate as being a very sensible and compelling choice for stationary storage.
Yeah, and I think what I would add to that is the EV market is going to continue to drive down the price of lithium ion. Already we're under $100 a kilowatt hour at the cell level, more approaching $50 a kilowatt hour. And sort of that, that scaling for electric vehicles is going to support, the ESS market as well. For those who are, hear thermal runaway and sort of to build on what Chuck was saying about the cobalt-based chemistries versus an LFP, the way in which it frustrates me, the standards don't reflect different types of chemistries, the standards don't reflect different voltages, right? We're a low voltage architecture similar to microinverters versus string. So, there's an inability to arc our low voltage 48-volt battery, right? With cobalt-based chemistries, in the process of entering thermal runaway, it actually produces oxygen, thereby perpetuating the thermal runaway event, whereas lithium iron phosphate does not. So that is, when they talk about thermal runaway, it is literally like fueling the fuel, and that's what creates the danger. We actually don't even have sufficient oxygen in our product to maintain and induce thermal runaway, hence why I said that during thermal runaway testing, we didn't heat up above ambient. You can hold it in the palm of your hands while it's 500-600 degrees Celsius inside. So just thought I'd add a tidbit on thermal runaway to help people understand the difference between LFP and the less safe and fires that you've seen from companies like Tesla in my homeland of Australia. That was high voltage and cobalt based chemistries.
Yeah, and that's a good point, Andrew, about the lack of discerning between different technologies, different chemistries, and so maybe that's get you on NFPA 855, and you can start changing the.
Well, it might actually, just sorry to hog the microphone, but I've been on a working group for NFPA 855 for rooftop deployments. So okay, the code, awesome. The 2023 code is going to see an amendment for rooftop deployments. If we've got some code junkies out there who are like, how the hell does Yotta deploy based on the direct reading of the code? There's a TIA that got voted on and approved on that I'm happy to share with anyone who wants that, that alleviates the onerous requirements for safe technologies like Yotta's.
Perfect. I was just trying to get you more work, so that's all. I was just trying to put more on your plate for you, so that's all. Okay, we're getting close on time here, so I do want to get this third question in. And how does your company support proper design and installation of your product? And I think there's a direct question that came in from one of the participants. Ty was asking, is it reasonable to expect electrical contractor to provide and install the BESS? And so I think it ties into this question here. And so, quite honestly, when we start talking about electrical contractors, installation, that's the most qualified people to be doing this for sure. But going all the way back to, Chuck, you've said this a few times, needing to have more education. I think that falls into play into here as well. But are there services that you're providing for your products?
So Socomec is a manufacturer and integrator. We are not an installer. The companies we sell to are installers. And I was asked this question when we were writing the installation manual. What are the requirements for the person installing it? And part of my job is always explaining the complexity of the AHJ ecosystem in America to Europeans. And really what it comes down to is, what is required in the jurisdiction where you are. And in California, that's probably going to be licensed electricians working on this stuff, but different places have different requirements. So ask your local AHJ.
Right. Well, and in code, it talks about, being installed or, installed by a qualified personnel. And so qualified personnel need to get trained and learn how to properly do this.
Right. So, we'll provide an installation guide. We'll give, so these modules are seismically bolted to a concrete pad. There's an anchorage study. There's a drilling template. So you're going to drill the holes per the template. You're going to bolt them down with the Hilti bolts as specified in the seismic guide. You're going to run the wires as per the installation manual. And then before we, as we're commissioning the system, we always have a staff technician on site to review and look over the installation, look for any things that may have gone amiss before we wake it up and put it in service.
James, relatively briefly, since you guys are, different technology, look a little different, maybe different than what others do, is that something that you are working with the contractor specifically on the installation side, since it's maybe looks and feels a little different?
Yeah, so I think the way Chuck described the scope that they participate is work maybe one notch below. So he said manufacturer and integrator, all we do is manufacture our solution. But for our customers, we need to help work with EPCs, work with integrators, work with whether it be a utility in certain circumstances on how to do that. So we support that with drawings and the installation packages and things like that to get them kind of ramped up on how to do that. And then that's kind of the role that we play relative to kind of the groups around our technology.
Cool. And somebody out there asked, it was an anonymous attendee, so I'm not sure who to attribute this to. And where can we find some good educational resources for ESS, specifically capacity sizing and good economics? And so, we at Mayfield, we do our own education, so there's definitely some help there. We do reports and we do studies on this as well, so around the economics and things like that. So kind of take that softball and take that opportunity to put that out there. But there's other ways of going and getting educated, working with the manufacturers, I would say would be a really big one. There was another. Go ahead, Andrew.
Yeah, and just so lastly on with regard to Yotta, it is actually mandatory for our customer success team to deploy to site for your first installation, whether it's with our batteries or just with our microinverters. We recognize that success exists well beyond just selling equipment to you. And we want to ensure that your customer ultimately, assuming this is majority developers and EPCs on this call, that they're ultimately satisfied with their system. And so, this is part of the infrastructure and also why it's named customer success and not operations. It's all about the success of our partners.
Sure. And maybe just if I misunderstood the question, obviously ESS has a customer success team and we deliver and commission all of our systems. I just meant in terms of the economics, the consulting, the engineering, there's a lot of other companies that support that. We take full responsibility for our technology, delivering that and commissioning that to the project site.
Awesome. So I'm looking at some of these other questions here, there's a number of questions. I just want to, and we're running low on time, so I just want to try and get another one or two in if I can. One of the questions hopefully we'll keep this brief, but this came in ahead of time. Since energy storage still basically PV plus energy storage still carrying kind of a high cost, and are any of you seeing a use case where batteries filling the role of providing that power for a very, very short amount of time while generators are coming online, to keep everything going, kind of a larger scale UPS, if you will? Is that something that you are seeing?
So it is a request we see often. It's often a data center request
Yes.
where we want switching speeds that are so fast the servers don't know the power supply has changed, and then a transition to generation or something else to follow. So Socomec does offer another product dedicated for that solution, but we also manufacture uninterruptible power supplies in a wide variety of sizes, and high power quality, no interruption, short duration is what UPSs are for.
Right.
And they're certified differently, they're installed differently, the codes and standards treat them differently. So it's a very reasonable question for a customer to want a battery thingy that's both a UPS and an energy storage system, but they are different things under the rules. So yeah. UPSs where things can suffer no interruption and power quality is paramount, and energy storage where some transition time is acceptable, but we're backing up more of the building and the duration is not measured in minutes but hours.
Right. So this, I think that gets into kind of setting the project up and getting the right project or the right products for that project, or understanding what those projects are. Okay, we're running right up on time. So I want to, key takeaways that we talked about, no one size fits all. We very much products use case specific. And so understanding what those use cases are, and, energy storage education has come up multiple times, both from everybody involved here in the call today. So definitely something that we're focused in on and wanting to help the industry with. And then of course, safety being a primary role. So, I just want to say thank you to the three of you. I really appreciate your time. This has been helpful for all of us. I do want to note there were a number of questions. I think it was Mark and oh, now I'm missing it, but there were some. We'll get them in touch. I think there's some very specific product specific questions. We'll make sure we make that connection. Of course, if you have other questions, we have our resources here, our contact information here. So thank you all for those of you on the panel. I really appreciate you taking the time to join us here today. And then finally, sorry, I know we're right up on time. So finally, next month, we're going to be talking about scaling workforce, role of education and training. So kind of building on some of the stuff we talked about today. So I guess any last parting thoughts from the panel before we say goodbye?
Thanks for having me.
I appreciate it. Definitely, there's more to be said. We could cover things in multiple hours. So I appreciate you guys taking an hour out of your day and joining us.
Always a pleasure. Thank you, Ryan.
Thanks, everyone.
Thanks, Andrew. Thanks, Chuck. Thanks, everyone.
Cheers.
Awesome. Thank you.